Okay, everybody. So it's 8 p.m. Central Time, 9 p.m. Eastern Time. Let's get started. This is an information session about our AMC 10-12 boot camp. So this will be, I think, running for 4 weeks for AMC 10. And for AMC 12, we will have an additional 2 weeks, so 6 week long. And so I have a few slides today, some information about our boot camp. And I would like to share with you some sample questions from the AMC10s. No sample question related to 12 today, but I think it should pretty much fairly give us an idea about what to expect for AMC10. Let me just give some brief information about what AMC10 is and what AMC12 is, just in case there are some new people here, and then I can say a few things about my philosophy. So AMC10-12 are part of this long marathon, if you want, where the aim is to select 6 people that will represent the United States at the International Math Olympiad. So in order to get to those 6 students, there's a long, year-long competition, if you want. So first we have the AMC 10-12 sometime in November, right? Followed, and lots of hundreds of thousands of students take those exams. And then we have if you are 11th or 12th grade, you have to take the AMC 12, right? But if you are younger than 10th grade or younger, you take the AMC 10, basically. And we have those who qualify for the AMI. The percentages change, so don't bother these numbers. So probably up to 5% of the contest takers, they are invited to take that AMI, American Invitational Math Examination. After that, those 6,000 students, the top 500, 250 roughly, about half of them qualified through the JMO, and half of them qualified through the USAMO. They take the USAMO and the JMO. Now, USAMO and JMO is slightly different compared to the other two. Yes, AMC 10-12 is multiple choice versus AMI is fill in the number, a number between 0 and 999, versus JMO and USAMO is a big change. It's proof-based exam. Right. So, I mean, multiple choice versus fill in the number is not too much different. They don't care about how you solve the problem as long as you get the correct answer. In the case of AMC 10-12, rigor is not important. In fact, a lot of students, they can solve the problems by just checking the answer choices and not really solving that's not the case at the AMI level. Because no answer choices are given to you, so you need to really work out a solution. And the case of JMO, USAMO is even worse. You have to have not only a rigorous solution, but explain to judges how you solve those problems. So in terms of style, these contests are different. The rest of the contests, like MOP, only 50, 60 students are selected each year for a summer camp. Math Olympiad program, or sometimes they call it MOSP, Math Olympiad Summer Program. Depending on funding, some years, earlier years, they used to invite about 100 plus students, but in recent years, it's more like 60 students or so. And now it's open to international students as well. During COVID, it became online, obviously, but then I think it's reopened. And then eventually the goal is to select those IMO participating students. That process actually takes another year. There's a bunch of team selection tests and so on. I think we are in the very first step today, right? And even the AMC 10-12, like the initial very first step, is in and of itself a big deal, right? Especially if you're taking the test for the first time. If you've taken it for the previously, you have some experience, and you know that AMC 10-12 is kind of something that a hurdle that you need to quickly go over, and then quickly, like the real mindset should be the AMI. AMI requires a lot of practice versus AMC 10-12. Usually it takes about 6 to 8 weeks, basically 6 to 8 weeks. It's just like in the Madagascar cartoon, 68 weeks. No, not 68, 6 to 8 weeks, like about 2 months, I would say. Don't study more than 2 months for the AMC 10-12 practice. It's just a contest which is based on speed. And let me just say a few words about that next. By the way, if you have any questions, feel free to either write on the chat box. I can follow the chat, or unmute yourselves. And so I'll be more than happy to answer any questions you might have. I also have a question answer at the very last slide, but I'm assuming that maybe some of you guys, you don't want to wait until the very end. So feel free to write on the chat. And if you feel like any of what I'm presenting, you have a question. So, okay. So AMC 1012, very quick, like test, 25 questions each, 75 minutes. So you basically have 3 minutes per question. It's very difficult to get a perfect score. Even the top Olympiad taking students, they can get a top score, like perfect score at the Olympiad, like 42 out of 42, but it's very difficult to get 150 points out of this whole thing. Because as you study more and more advanced questions and like harder questions, you get slower and slower. AMC 1012 is more like MedCount style, speed and to a certain extent content, but not as much. Yeah, if it's your first time preparing for AMC 1012, okay, here's the deal about our bootcamp. We will assume to a certain extent that in terms of content, at least our bootcamp is structured like that. In terms of content, you have no gap. So the real intention of our bootcamp is practice, right? It's just a very quick boot camp, 6 weeks. We're assuming in terms of content, you don't have any gap. I'll show you some of the topics that we cover. So if you feel like you have some gap, maybe the boot camp will not be as useful, I would say. But usually the material, we keep it for six weeks, about 6, sometimes 8 weeks up on Canvas. If you feel like you want to look at it at your own pace afterwards. But yeah, so if in terms of content, you have some gap in your knowledge, the bootcamp will be challenging. Yeah, so I just responded to a question asking whether we should consider taking AMC 1012 bootcamp or Contest Math 401. It depends on your own personal assessment, I would guess. You can also send an email to info@momentumlearning.org. It's directed to my wife, who is the academic director. Sometimes she might give further insight if she knows the student, but it is, yeah, so it depends kind of. I would personally say most of the topics in AMC 10, like, I don't know, maybe 80-90% is mostly math counts, but there's the 10-20% topics that's beyond that, right? So for instance, conic sections, or I don't know, like in number theory, Euler theorem or Fermat's Little theorem, you need to know just a little bit of content beyond math counts, which, yeah, it's a tough choice. I would personally choose 401 if you feel like, yeah, so yeah, so that's all for I can say. But yeah, in our class, we will assume that you guys more or less have the content covered, and the bootcamp is basically brutally solving a lot of questions so that you guys can practice. Like usually AMC 10, like students who are taking AMC 10 for a second or a third time, they just study minimal, like 6 weeks or so. Your job is to basically qualify for AME. As long as you qualified for AME, it doesn't really matter too much, the AMC 1012 score. And students who are more or less experienced, they feel like, okay, so all I need is a lot of practice questions and you feel up to date. Like, but if it's the first time, then it's a big hurdle and it's challenging, yeah. Okay, so I hope it more or less addresses the question. All right, the exam dates this year, AMC 1012. Now, compared to, I think it was back in 2021, it used to be that AMC 1012 used to be given in February, AME used to be given in March, and then USAMO JMO was in April. They realized that there's not enough time to grade the papers, and the Mathematical Association of America, in terms of resources, I think they had kind of limited, and it was very challenging to organize 3 important contests back to back. So they started like administering the AMC 1012 ahead. Like in this case, in November now, it's really ahead of time. I think like our camp dates are really nice. We start, I think, in September 8 or 9 or something like that. I'll show you the dates in a few minutes. And then we finish before the end. Like I think we finish by the 3rd week of October. That's I think like 6 weeks. We focus intensely on these subjects and then we move on, right? So because that's the whole point of AMC 1012, just to make sure to identify like the students who are serious about it. Like hundreds of thousands of students are taking the AMC 1012, but only 6,000 or so students are invited. And I say invited, emphasizing it because this is AMI, American Invitational Math Examination. So only the top 6,000 scorers or so, they are invited to that contest, which takes place in the spring, right? All right, so we have kind of like a structured curriculum that I think Miss Nall and her math teachers and myself included, we've been kind of experimenting over the years, right? So it's been almost 10 years. We had quite a lot of successful students over the last 10 years. And sometimes I wonder if as a teacher, I'm amazed by how smart our students are. And I feel like I'm learning more myself rather than so it's a great experience on both sides. It's the reason I'm doing this is pretty much I'm enjoying it a lot. And I hope this for the students, it's also a joyful experience. But yeah, the curriculum is very strict. The contest, is becoming more and more popular and becoming harder and harder. Compared to even 10 years ago, the amount of material available has increased exponentially. Like 30 years ago, there was almost no material whatsoever. The contests weren't well publicized, but since the early 2000s, and especially since 2010, they've restructured the contests. Now they are very well established. For instance, there was a lot of concern, let's say, just as an example, like moving from AMI to proof-based problems to USAMO. There was no JMO previously, and now they included a JMO. So 9th and 10th graders, they are able to take the Junior Math Olympiad, which is, in terms of proof style, it's easier than the USAMO. So there has been a lot of pedagogical improvement to the whole official curriculum. And our curriculum at Momentum Learning, we adapted to that as well. And so we created this kind of multi-year program, depending on how far you can go, right? So some students, it depends on the personal needs of the students. If the goal of the student is just to qualify for the AMI, I guess the student can go all the way up to CM Contest Math 501. And I think this class will provide sufficient material and practice to the student to qualify for the AMI, right? But it is truly a marathon. It's not like math counts. Sometimes I chat with folks. If a kid is smart and he starts studying math counts, within a few months, like maybe 6 months, the student can become really competitive, right? So, but in the case of this USAMO track, if you want, starting from AMC 10 to AMI to JMO to USAMO and so on to MOP eventually, this is very, very challenging. And not everybody is supposed to make it to the USAMO, and that's perfectly fine, right? It's like, you know how, think about in colleges, sometimes we have athletes, their body is very strong and they practice all day long at college from 6 a.m. in the morning till nighttime, and they become exemplar in terms of what your body can do. But not everybody can become an athlete, student athlete, right? So maybe, I don't know, at most 10% of the student body becomes student athlete. So that's one extreme example, but we are inspired by those student athletes, and we try to become like them. Like we want to exercise. They are our role models. Similarly, we have very smart kids, right? They eventually qualify for the USAMO and they represent the US at the International Math Olympiad. They are a very small sample of students. And just like the student athletes, so these are mathletes, everybody inspires to become like them probably, right? So it's great. So here we have some role models. Not everybody will be able to achieve that, but we will strive, right? Personally, when I look at myself, my own development, I don't know, maybe I was like 90 percentile. I wasn't in the top 1 percentile when I look back, when I like my own journey in high school or college. But one thing that I learned was sticking with the math community. It's great. Like you make very good friendships, you are inspired, and that's what matters the most, if you ask me. These contests are great and everything, but eventually when you go to college, or those of you who do research, some students will do research, for instance, you realize that it's all a team game. And when you prepare for these contests, students, they develop friendship, they develop studying together, they ask each other questions. It's perfect. So they are preparing like both mentally, like in terms of skills, some sort of math appreciation, but also they learn how to like how to work together with like-minded folks. And this is the most important things. I like, I mean, sometimes as parents, we try to kind of help our child navigate and like push them a little bit, I guess, and eventually hoping that they will be inspired. I think that's perfectly fine. And you just keep looking, right? So for instance, I usually tell my students, in 9th and 10th grade, it's good to keep doing math, especially if you did math counts previously. But eventually at 9th and 10th grade, it might be a good idea to start diversifying our portfolio, right? The math curriculum is great, but not everybody is going to be a mathematician, right? So you will have engineers, you will have all sorts of chemistry folks, physics, finance. A lot of students go into the area of finance, especially students who are good in counting or computer science and so on. So this is great. Just today I learned that Evan O'Dorney, he was a math lead back in 2000s, I think 2009 or 10. Several times he qualified for the USAMO. I mean, he represented the US team at the IMO and so on. He became a professor at Carnegie Mellon University. I mean, one of the top universities in the nation. I mean, yeah, so those folks are like kind of like really good examples, but we inspire, like we're inspired by their examples, and we want to do our best. We want to see if we can like, given the skill sets we have, can we improve them? And I truly believe it's possible. It all depends on inspiration. Like if there is something that you like in life and you keep doing it and you have fun doing that, I think that's one of the things that I learned a lot from my own personal life. Like I enjoyed so much the math community. I learned so much from that community. But anyhow, so the top green part is the fall spring semester, and you guys can see the AMC10 is somewhat like a student who is as early as contest math 301 or 401, 500, 501. I think these students should kind of do some preparation. If you're already a 600, like contest math 600 at momentum, let's say, I'm assuming, so probably you are okay. I mean, for AMC 10. If you are planning to take AMC 12, yeah, maybe you need further practice, but for AMC 10 purposes, you should be fine, I guess. All right. So the bootcamp dates that we have at Momentum, like we have, I think 4 lectures, 2 hours each. When I say lectures, it's mostly like problem solving, like I said, very fast pace, not covering as much topic, but rather the focus will be on practice, basically. And then there will be TA sessions, 4 TA sessions each week, 1 hour each. And we will have a mock exam, a 2-hour session in the end. So in total, I think there will be 14 hours of instruction, which is fine. Obviously, there will be homework, and that's why we have the homework session. The dates are here for those 4-week sessions. We have this year a beginner and an advanced track. So for instance, the earlier question we had whether to take 401 or AMC10. I don't know, if you are planning to take both, maybe the AMC10 beginner track might be a better option, obviously. If this is the second time you are taking the AMC10, or maybe the third time, then maybe the advanced track might be better for folks. But the dates are here, basically. The dates for the actual lectures, then the dates for the problem sessions with the TA, the instructors. The first 4 weeks programs, we have Dr. Robert Burridge at the beginner program and Miss Null at the advanced program. And then the last 2 weeks, if you're preparing for, where is it? AMC 12. Oh, these are the topic. But for AMC 12, we have 2 additional weeks. And so I'll be teaching those additional weeks, basically. Okay, so let me go back. So these are basically the 4 areas in contest math. These areas are the same. And because our camp is 4 week long, so we decided to cover 1 subject every week, except that it looks like geometry has slightly more weight than number theory. That's why the geometry topic in the second class a little bit of it, we will cover it during class 3. So a portion of class 3, we will continue doing geometry, and the rest of it, we will do number theory. Yeah, but the topics are, I think, kind of okay. There's a few additional topics that is not covered in middle school, like logarithms, which is a special type of function. Trigonometry is not covered in middle school. Conic sections, hyperbolas, parabolas, and ellipses are not covered in middle school. So especially in AMC 12, you see more of these. In AMC 10, just a few of those. Yeah, any questions about this? Some topics are slightly challenging, like I'll show you 4 examples of problems. I tried to pick 1 example from each topic, and like, if you ask me, most of them are kind of like, given the skill set, it could be done. Like, you don't necessarily have to use advanced topics, but if you know the advanced topic, usually there's a shortcut, right? You can make the calculation faster, basically. Yeah. Okay, so, all right. I don't know if I'm going too fast. Yeah, let me, okay. And yeah, so like I mentioned, so we have AMC 10 is just 4 weeks. For AMC 12, we'll have 2 additional weeks. All right. For like those 2 additional weeks, one of those weeks we will study those advanced algebra topics, which includes topics that, like, for instance, complex numbers is usually part of, like, pre-calculus topics, trigonometry, complex numbers, roots of unity. So those are like not part of the AMC 10 curriculum, but rather the AMC 12 curriculum. But like I said, I will assume that the student more or less knows the subject, and we will just solve problems, basically. All right. The problems that we will solve, like, will be mostly from either prior years AMC 10-12 problems or from similar contests. And usually there's a list of contests that I suggest my students in general. Like some of my favorite contests include the ARML, the Purple Comet, the Mandelbrot, the Math Prize for Girls. At the university contest math level, obviously we have the HMMT, the PUMAC, the Stanford Math Contest, and Carnegie Mellon math contests, and so on. So there's a lot of like contests that the student can make use of to practice. Like I said, you don't want to over practice it. Like, if you ask me, 2 months should be sufficient to practice that, and then you should move on to AMI. AMI is the real deal. AMI is a challenging contest. Already, like the pool of students taking the AMI are very, like, the top 6,000 students in the whole states, and then, like, you want to be a JMO qualifier. Being a JMO qualifier is a really big deal, especially if you are applying to a STEM field at one of the technical schools like Caltech, MIT, Georgia Tech. So usually they ask your AME score, your AMC 10, 12 scores during the admissions process. So yeah, so this is great. All right. So yeah, so sometimes, like I already gave you a few examples of what's so nice about, like, why should we study the math, like the contest math, or in general extracurricular math. It doesn't have to be contest math. Like some of my high school students, for instance, they do research with their college professors. That's great. The goal is to inspire the students, to tell them that, hey, there is a whole world outside school curriculum. School curriculum is absolute minimum, bare minimum skills you need to be successful in college. But we're not doing it because, hey, this is like something we have to do it. We're inspired by it. And like I said, a lot of students, they go way beyond these, right? A lot of high school students, every year they approach their like the universities in their hometown and reach out to professors and ask if they can do research. And usually I tell my students, hey, you don't have to do a math research. Approach science professors, right? Physics, chemistry, biology. Like, hey, so they just do research. And if you ask me, like, ultimately the goal is the transition into that realm of like inspiring the students to do additional work on their own, right? So that's the best. And I think like I said, there's a lot of opportunities today compared to 20, 30 years ago. It's great, but it's also a curse. Because there's so much opportunities, you have to be somewhat selective about like what compete, because it can burn out eventually. Like if there are certain competitions you want your kid to participate, I'm telling the parents, or similar for students as well, if there's students here participating, like you guys have to have a good schedule, and which weekend we're going to which competition, like which weekends, I don't know, like it's good to be very organized, or like, and so this way you can plan way ahead of time, and the student knows it, everybody is committed, the whole family, right? It's sometimes you feel like the student needs a lot of support. It's no different than, especially if the student is serious about contest math, it's no different than athletics, right? You know how athletes, they have a certain regimen, like a schedule where they practice. And this is, if the student wants to be serious, like you can take it extremely serious, and you can make, there's a whole world where you can discover a lot of math, and it requires a lot of parental support. There is no way without parent support the student can do it on its own, because there's a lot of logistical issues that only can be resolved with the support of the parents. Like and yeah, so it's challenging. Like if your child is swimming, let's say, and he needs to swim before school every morning, so 6 a.m. you need to drive him to that place and so on, right? So there's similarly, if there's a math practice, there's a math club in your local school, you have to stay after school for the math practice. And so there you go. So there's a lot of logistical things to so it's a sacrifice on everybody, the parents, the student. And yeah, so then there's decision making, a lot of it. Like I said, there's a lot of, like, you can be excited, it's a lot of fun. I mean, okay, so we can mention a lot of things. A lot of these students, like I said, once they are inspired, they keep going on their own, right? The only thing, like if you want to inspire your child which is hesitant whether to do contest math or not, especially some students at the very beginning can be intimidated, take them to a contest. Like if you have a regional or local contest, take them and let them like mix up with other students. Like ARML is a great contest. Like in Texas, we had great contests. Like Texas A&M has a wonderful contest where students from Houston, Dallas, nearby cities, they drive, and it's a great way to socialize. And once the students, they go, oh, okay, so it's a fun thing. Yes, there are winners, but it's perfect. Like no one says anything. Like participating in and of itself is a great deal. I mean, it's a great thing, and they appreciate that. Great weekend spent together with family, friends. It's wonderful, especially if you can find, like, if you are in a school and not so many people are doing contest math, if you can inspire other parents, like if you can find like-minded 3 or 4 parents where their kids can study together, it would be really much better. Like in general, it's challenging to do it on your own. The student has to be extremely like motivated to do it on its own in general. But if there's a few students doing it, it's a lot more fun, I think. Anyhow, you improve your problem solving skills. Like there's so many benefits of doing math, not only contest math, right? So like all sorts of math. There's a whole, like you can do contest math, you can do recreational math. There's a lot of great math that they can learn that's not towards contest or research math. These are all great things. Yeah, so you learn how to collaborate and so on, and you are part of a great family. Like a community. The math community is great. Yeah, so students learn discipline and organization, like I don't know, like just like athletes, like it takes a lot of, they realize that you have to be very organized. It's not like you solve a problem and then you throw it to the trash once you solve it on a piece of paper. No, you need to be organized because it's building up, knowledge builds up, and they need to learn how to keep their notes carefully, like in notebooks, so that later on, if they are working on a problem and they remember, oh, wait a second, I solved a similar problem, they should be able to find where that problem was. So if they are organized, that helps a lot. And yeah, so, and you make some parents happy. Well, obviously, so like knowing that your child is motivated and doing math or science for that matter, I mean, no parent can say no to that. I mean, you know your child is safe and in the company of good folks and so on. All right, let me see. If there's no question, I have a couple of example problems if you want. I don't know how many students are there here in the room. I can even skip that. But let me just show you a couple. If you if it's boring, let me know. I'll just skip it. Last time I had a session about AME and I didn't have time to go over the problems, and then I felt terrible about it. So I selected some harder end problems. So these are, for instance, this one was the hardest problem a few years ago in a contest, and just an example of I want to present 2 different solutions. In one of them, I use a little bit theory. So knowing some advanced knowledge, how that can... Oh, question? Oh yeah, let me know if there's any question, or you can write on the chat box. Like I said, I'm recording this session. If any students later on watch, they can also see it. Like I said, some problems, like most AMC10 problems, you don't need to know advanced topics. If you know it, sometimes there's a shortcut, easier to solve the problem. But otherwise, you can still solve it using just pure logic, but not always. Like if it's a pure, let's say, logarithm, polynomial, trigonometric question, for instance, student needs to know the content. Just for instance, in this example, we are told the student is taking 7, oh, more. Should a grade 10 student take 2 AMC10? Oh yeah, this is the hardest question. Should a grade 10 student take 2 back-to-back AMC10s, or 1 AMC10 and 1 AMC12? Yeah, it depends. If you felt really good about your first AMC10, then the second one, students take AMC12, I guess. Yeah, so it really depends. But if your first exam didn't go as planned, I don't know, so probably taking another AMC10. It also depends on, like down the road, do you want to take the JMO or the USOMO? Some students, if this is the second time, like they already qualified for JMO in the previous year, they've spent a whole year studying further Olympiad math, they feel like they can make the cutoff by taking the USAMO. Making the cutoff in JMO and making it to the MOP is sometimes harder. Like I still remember a couple years ago, I had 4 or 5 students. Out of 6 questions, they solved 5 of them perfectly. They got 35 each, and the cutoff that year was 36. So it was insane. If you wanted to make the cutoff for the MOP that year, taking the JMO, you had to solve out of the 6 Olympiad question, proof-based questions, you had to solve 5 of them perfectly, and the 6th one, you had to say a few words about it. Interestingly enough, only one of my students qualified that year, but the following year, 3 of the 4, which the previous year they couldn't, they all qualified for the MOP. So yeah, so that's why I usually tell my students, hey, it's a long journey, so don't like, hey, like don't try to make it, like, take your time. And yeah, so it's also a mindset in that sense. Any tips on the time management during the test, taking how much time to spend on? Yeah. Yes, so I'm assuming, like, if the student is coming fresh out of math counts, let's say if you're an 8th grader, usually in terms of time management, 8th graders are better. Why? Because they've already done math counts. In terms of speed, they are pretty good shape, and they spend, like, you have to solve the initial questions pretty quickly, so you save more time to the harder end questions. But the concern is, so it happened in the past to my students, when you go very fast in the first few questions, then you start making silly mistakes and you start missing very easy questions. So that's why practice matters. So, and like I said, maybe 5 or 6 weeks practice for just AMC10 is kind of useful. It's kind of a distraction. If you've already qualified for the AME the previous year, you feel like, why do I study for AMC10 again? Because AME and AMC10, the style is different, right? So it's a different test-taking strategy, multiple choice. For instance, because I can see the choices in this problem on the screen, I can even make a guess, like, I don't know, there's a different skill set involved, I guess. Yeah. How many, for qualifying AME, should one take AMC10 or 12? Either one works. Let me show you the, oops. Let me, yeah, but there's 2 tracks you can use. Both tracks lead to AME. I think they have more AMC 12 test takers qualify for the AME. They like more seats available, but you can qualify for AME taking AMC 10 as well. Either track works. So if you are an 8th grader, you can take AMC 10. AMC, well, obviously, if you are an 8th grader, you can take AMC 8 as well. But okay, so that aside, any student who is 10th grade or younger, they can take AMC 10. And if they score on the top, let's say 2.5%, 3% of the test takers, then they can qualify for AME. Or if you are 11th grader, you have to take AMC 12. Like, there's no choice. But if you're 10th grade, you can opt to take AMC 12 if you want to take the USAMO. It's very rare. Most 10th grader and below, they usually take AMC 10. Yeah, so oh wait, I think there was a couple other questions. Except AOPS's Introduction to Geometry, is there any other good geometry book? Yeah. AOPS has a wonderful algebra and combinatorics books at the intermediate level. Intermediate algebra and intermediate combo are really good books. I love those 2 books. Unfortunately, they don't have similar level quality. It seems to me. I mean, I love AOPS public. I love them all, right? But in terms of, yeah, geometry, I don't know if it's because geometry problems take so much space, like, so that you put a picture for the problem and then another picture for the solution. Maybe it's not economical to publish a geometry book because there's so many topics and so on. Yeah, I don't know any good book related to geometry, to be honest, at that level, at the intermediate level. At the introductory level, yes, AOPS geometry is good. At the intermediate level, yeah, I don't know any good book. As it appears, the most difficult AMC10 problems seem relevant geometry. Yeah, you can say that. What I can recommend is the at the high school curriculum, I think you start learning about geometric transformations. And so that's a good topic so what, like usually I aim for, I think it's a good in practice. Like if you just like learn just enough, barely enough to take a test, pass a test, maybe you won't pass. And so it's best to study harder things. And so this way you can pass the easier stuff, right? Usually practicing AME is good. You learn new concepts, and as you learn new concepts, that can help you with solving easier problems as well, a new perspective. The only downside of learning harder topics is you slow down, and that's sometimes you overthink, and AMC10 is no overthinking. You have to have some really good logic and efficiently solve a problem. Keep an eye on the answer choices and just bubble the, like sometimes you just test out different answer choices quickly and so on. So what if we are in 10th grade and it's our first experience with AMC? Do you suggest us to take AMC 10 exam this year or start preparing? No, take AMC 10 if this is the first time. Yeah, it's also psychological. Like you don't want to get overwhelmed, just like athletes, right? So there's a mental game happening at the same time. So you start taking the test that morning when you're taking the test, or that afternoon, you have to feel very confident and relaxed. So there's a lot of things going on. You shouldn't blame the students. I mean, remember yourself as parents, right? 20 years ago, 30 years ago, you guys were taking those tests, and sometimes it's nerve-breaking. And I think like students, they should feel like they are being supported regardless of the outcome of the exam. And yeah, so like students, sometimes they pretend that they don't show their like sometimes how nervous they are, but like if they are enrolled in a course like any of these contest math related courses, and they care, I'm assuming they care because they're spending so much time. How do you register for the AMC 10-12 tests? Usually there's a coordinator at your own school, a math teacher that needs to order it. So you need to talk with the math teacher at your own school, I'm guessing. If you're a homeschool student, your parent can order it and you can take it. Yeah, AMPS Volume 2 or Volume 1 might be useful, especially for AMC 12. Yeah, to a certain extent, it can help with AMC 10 as well. Yeah, AMC 10 is mostly like solving like assuming that you know the concept. AMC 10 questions are not very deep questions like AME question. For an AME problem, you have 15 minutes. There's a lot of bookkeeping. In AMC 10, there's not much bookkeeping. The idea is supposed to be simple. You're supposed to not overthink it. And either you solve it or not. You have only 3 minutes. Reading the question sometimes and understanding it takes a whole minute sometimes, right? So so it's usually being very efficient. And so that's why I usually recommend, hey, practice about 6 weeks. I think it's 6 or 8 weeks is a good time to practice those exams. And as soon as the exam is over, such a relief, and go back to AME. In general, students, I feel like they like AME topics more because, like I said, time is no longer a constraint. You have 15 minutes. You can think a lot. And if you want to bash a question, like you can. At AMC 10, no. It seems like in AMC 10, there's a trick, and either you see the trick or not. The more you're exposed to like the more practice you do, don't over practice. That's one. Like you don't want to focus. Your focus shouldn't be on AMC 10, really. Like AMC 10 is just a hurdle. You need to quickly pass that. Obviously, if it's the first time you are taking it, it's a big hurdle. But if this is the second time, you know the drill. So last year you took it for the first time, maybe you failed to qualify for the AME. Now you feel, okay, so what was the problems you encountered last year? Like what were the challenges you encountered last year? What lessons did you learn from it? And boom. It's a mindset. like 2 months ahead of until the exam. You just every day you do your practice. Make sure every day you do a certain amount of practice, at least 1-2 hours, I'm guessing, so that you feel very confident that in terms of the test taking style, you are ready to take the test. Multiple choice tests are not very popular here in the US. They are very popular in other countries, right? But here in the US, it's not as common. And as a result, our students are in general very naive. Like when there's a multiple choice question in front of you, you have to be very strategic. Like I said, you don't have to solve the question rigorously, right? You start solving the problem, you get the idea, and quickly you can even check the answer choices. A lot of times, only one of them makes sense. You just have an eyeball answer. Okay, so the answer has to be somewhere in this range. I am boom. So, and then that's it. You just solve it. So it doesn't have to be very, very rigorous in whatever way. You just bash your way, and yeah. But volume 1, 2, AOPS volume 1, 2, what they call it? I think I have it in my library as well. It's been a while since I looked at that book. Yeah, so those books are not bad. Yeah, so that they can be used. All right. I have practiced with all the AMC10. That you did wonderful. If you practiced with all the AMC10 past exams, I think you should be ready. But okay, so if you want, because we still have another 2.5 months, or wait, September, October. Yeah, we have about 2.5 months. If you want to do further practice, I would, yeah, the contests that I mentioned earlier, they might be useful. Like those contests are also useful for AME contests as well, like the ARML, the Purple Comet. You can find the archives for those contests. Yeah, so I think you might have overstudied. If you did all of it, I think you're ready. If you studied all the past AMC10 problems and you feel confident, I think you are in good shape. Yeah, so I think you should be fine. Awesome. So you know what? Let me just skip through all this. Oops. Oh, I'm sorry. Let me share it again. I'll just quickly show my like a few questions if you want, but I don't want to like, yeah. So oh, sorry for that. I lost my chat box. Okay, there you go. For instance, an algebra number theory problem. I wanted to provide two solutions. The left solution is more like rigorous. It makes use of Chinese remainder theorem. And okay, so but the second one is a really smart idea, which is most likely if you are doing the test, you will solve it this way. You will test out different values. Like for instance, in this case, if the student has taken 7 tests and each of the 7 scores are different scores between 91 and 100, then you might do hypothetically, you can say, what's the worst case scenario? She took the 7 tests and her scores in the worst case scenario are 91, 92, 93, 94, 95, 96, 97, right? Because the scores are distinct, we are told in the question statement. Okay, so the sum of those numbers is equal to 658, and there you go. So this is the smallest possible sum. Or alternatively, the best score that the student could have taken in those 7 tests could have been 94, 96, 97, 98, 99, 100. Oh, wait. So 94, 95, 96, 97, 98, 99, 100. Yeah. So, and the sum of those is 679. Now, in the second approach, you know how you see how you are focusing on the numbers just from the get-go. Like you look at all the possibilities. So I'm assuming you guys have like strong math count skill, versus in the first solution, this is kind of like a rigorous solution where it's abstractly solving the problem. Like I said, most math count students will probably solve it the second method. Though if you started working on AME contests, you might like over time, sometimes students, they get slower and they try to solve it in a rigorous way. You don't have to. So for instance, in the second solution, as soon as you write the list of sums, that could be the value for the sum of the first 6 test scores. Then you just look at the answer choices and only one of them can make sense. You know that the answer choice must be divisible by 5 and boom, only the last choice is divisible by 5. So there it is. Not like it is strategically solving the problem, right? So like in terms of test taking, it's slightly different than taking the AME. I have, yeah. Okay, so I think I answered that question. So here's another example. Well, okay, so the same thing here. The only difference in this one is hyperbola. The word hyperbola, even if you didn't see it while in middle school, let's say that you are an 8th grader taking the test, you can still solve the question because there it is. The equation is given to you. X times Y equals 1. So almost nowhere in the problem we make use of the shape. I know the shape is kind of, the student can derive it. This is the most commonly like remembered shapes, like the hyperbola. This is a very well-known hyperbola, and you can solve the problem accordingly. So I'll just skip this one. Yeah, so these problems, like for instance, in this problem, okay, so we are given a huge number, 21 factorial. We are told it has over 60,000 positive integer divisors. Most students, when they attacked this problem back in 2017, I think it was, they started like this traditional way, like first prime factorize the number using Legender's formula, then figure out what a typical divisor will look like. And then as they worked out, like, and then among all these divisors, how many of them? This many. Because you want your divisor to be an odd divisor by the question statement. Okay, so you realize suddenly that all that matters is the, like in the divisor, you don't want any 2's. And suddenly it dawns on you that, okay, so that's the, but if you studied for AME previously, there's a lot of AME questions of this style. So it's a matter of practicing. So if this is the first time you're seeing a problem like this, it's very difficult to solve this problem in 3 minutes. But the more you're accustomed with contests and so on, like AME or AMC 10-12, I think, yeah, so this is doable, I guess. This problem, I don't know, like these type of problems has become more common. This problem is about graph theory, and graph theory is a very exciting area in mathematics research as well, like network theories, graph theory, heavily studied, and it has become more and more popular at math contests as well. So this problem turns out to be an Olympiad problem. They changed the problem, made it simple, and they ask it as if it's an AMC 10 question. But technically, like there's a whole Olympiad questions related to this subject. In this particular case, we realize like if a team A beats B, B beats C, and C beats A, like 3 teams playing and each one is beating each other in a cycle, instead of counting the cycles of teams beating each other, we can count the complement, where one team beats 2 other teams, or one team loses against 2 of the 3 teams, like in the cycle. And yeah, so but yeah, so this topic is somewhat advanced. If it shows up, it's not exactly there aren't many problems related to these type of subjects, but it's becoming more and more popular, more and more questions related to these type of graph theory and network. Okay, so I'm just wrapping up. Basically, this is our website. If you guys want to learn more about our curriculum, this is one thing that I'm kind of like proudly say that we have a pretty solid curriculum, which I think Miss Nal, our director, she developed over the last 10 years, and we were able to test it on a lot of students, and a lot of students, they did really well in contests over the last 10 years. I mean, I feel like we both sides benefited. We learned a lot from our students have learned a lot from us. We learned more or less over the years what's important, what's not as important. Like I said, when it comes to AMC 10, it's just there's this 6 or 8 weeks window during that particular year, time of the year, like in our case, September, October, where the student will have to focus on AMC 10. And then, yeah, so you just do it. for those of you, if you already qualified for AMC 10 last year, continue your AMI practice, but make sure every day you spend about 1 hour practicing AMC 10. And then once you do that 1 hour practice, go back to your AMI practice, basically, especially if you are serious mathlete, right? So, yeah, so, and this is our email address, the phone number. I'm not sure if there's any further questions. I tried to take as many questions as I could. Like I said, there isn't if you attended my previous session about AMI, you would notice that I gave a couple of book suggestions. I cannot give exactly book suggestions for AMC 10. Yeah, it's just a test that yeah, it's just there. You just focus like in terms of a mindset, and then just temporarily on that contest and then move on, right? And then the main attention should be at the AMI level. If a student is preparing for the AMI one way or another, like they will definitely pass the AMC 10 or 12, right? So that's why it's kind of good practice to, okay, so focus on that, like hopefully like learning the AMI topics will help the student greatly. Yeah, so I didn't wanted to present like more technical cutoff points and so on. You can go to AMC 10, the American Mathematical Association website, and in that website you can see the cutoffs over the years. One thing I usually like recommend my students is, if you want, and this would be my last advice in terms of strategy or tip, I think it's a good tip. Like if you are planning to allocate 8 weeks, or like right now we have about 9 or 10 weeks till the exam dates, I would recommend every weekend solving one test from one of the old tests. All right, so that would be, I feel like a very good way to practice it. And because you know the cutoffs from those years, it's already published on their website, the MAA website, the Mathematical Association of America website, maa.org. So what you can do is you can judge if you can qualify for the AMI by taking these tests. But you have to be very strict, like give yourself 75 minutes and then just check the answer key on AOPS website. You can find all the answers. The parent can sit like with the student over that weekend, and if you have time, take 2 exams, one on Saturday, one on Sunday. But everybody is so busy, I don't think you need that much. So probably if every weekend you are solving one test, that will give you an idea of if you are making improvement. If you feel like you're a little bit behind, like it looks like your test scores are not sufficient, so then you might have to maybe solve 2 practice tests every weekend if needed. By the way, this is exactly the same suggestion I would give for those of you preparing for the SAT. Same idea, right? You go to SAT website, they have 8 practice tests. 8 weeks is probably sufficient for the math component of the SAT, right? Every weekend you solve 1 SAT math test, and then you check your answers and see if they are reasonable within the given range. All right, so well, thank you so much for joining the session today. We really appreciate your time. So we recorded this session, so feel free to revisit a Momentum Learning website if you want to, if there are certain things that you wanted to watch again. Hope to see you guys, any one of you, if you are planning to participate in our AMC 10. So Rong, do you have a question?
Yes, thank you, Dr. Nao. I do have a question regarding the starting date, because we got email saying that the AMC 10 advanced is postponed to 16th.
Oh, I didn't know that. I'm sorry. So that's kind of okay, because I think we had 2 or 3 weeks at the very end. Like there's still some time between the actual test in middle November and our classes. Did you count the 6 weeks? So if it starts on September 16, when does it end? Is it last week of October, I guess?
Yeah.
Okay. Yeah, I think it's okay. But yeah, I didn't know. Apparently Miss Null changed the schedule. I'm sorry for that.
It's okay. I just wanted to confirm it will start on 16th.
Okay, so
Yeah.
so
Yeah.
whatever is the website, the website has the most up-to-date information. Yeah, so my slides were prepared. I think I prepared them about 2 weeks ago. So yeah, don't trust my slides. So check the website. I just
Okay.
copy pasted from the website back in the day.
Okay, thank you.
Okay, thank you. All right, everybody. If there's no other question, all right, so I'll conclude the session. Thank you and have a great weekend. Bye, everybody. Oh, are the problems on the class the real exam problems? So usually we pick problems from a variety of tests. We try to diversify. Over the years, like I said, my favorite contests are the ARML, Purple Comet, Mandelbrot, Math Prize for Girls. We have like gathered some problems, some pretty good, I think decent problems related to AMC10. And sometimes we solve AMC10, 12 problems as well. But so those are my main contests that I refer to in general. Those are high quality contests, as well as some HMMT and PUMAC as they are related.